question 5, you have to draw the circuit that you would use to collect this data. So this is the basic circuit that you'd use. The marks that were available, there was a mark for showing a suitable power supply, but it's very important you show that it can be varied. So if I stick that symbol there, that tells that is a variable power supply. The examiners would actually prefer you to have used a potentiometer, sort of potential divider type of arrangement, but they can't penalise you for drawing that because that's how we would do it. We'd turn up the voltage on our power supply. The other marks, you've got one mark if you've got both the ammeter and the voltmeter drawn correctly. So obviously the ammeter's got to be in series, the voltmeter's got to be in parallel with the diode. The third mark that was available, to get that you had to make sure that you put this resistor in series with the diode. That's a protective resistor. If that resistor wasn't there, once the diode started conducting, once you got the voltage big enough, the diode would start conducting, you get a huge current and the diode would just burn out. So you must have a protective resistor in circuits with diodes. And along with that, you had to show the diode the right way around, what we call forward biased. So in this circuit the current would flow that way, the diode would conduct. So 3 marks for that. There are up to 6 marks available for your description of how you would do the experiment. And those marks are a combination of the points that you make and how well you express yourself. So let's look at the things that the examiners said that they were looking for. Refer to the fact that you connect the circuit up. That's an easy mark. Refer to the fact that you measure the current and you measure the voltage. And I would say not just refer to the fact that you measure them, but that you measure them both and you record them both. Some people said that you varied the voltage and you measure the current. Well, you've got to measure the voltage as well, and you've got to record them both. Referring to taking a range of results. And one of the things that's important, of course, is that a diode, its behaviour does change significantly over a narrow range of voltages. So it would be no good saying that you're going to take readings every 1 volt, because if you go from 0 volts to 1 volt, you've missed everything that's of interest. To explain that you take lots of readings between 0 and 1 volt, and then fewer readings outside that range. It's also important for a diode, of course, that the whole point of its behaviour is it behaves differently when connected in the forward direction to the backward direction. So you should say that you reverse the connections to the power supply and repeat the experiment. Now some people just said that you would use negative voltages. Well, we do have a few power supplies that give positive and negative voltages just by turning the dial, but it's more usual that to get negative voltages you just reverse the connections. And the whole point of this is that you're investigating the characteristics, so you've got those results, so there's a mark for saying that you plot a graph. And this is the exam board's mark scheme. They say plot a graph of PD against current. So I think they've made a mistake because it actually asked them to plot a graph of current against PD. Because that's the normal way we draw diodes. But anyway, it's not our job to pick fault with the examiners. Part B gives a circuit involving a diode. And it's very important, as soon as you see a circuit involving a diode, you've got to sort of focus in on the diode and realise that you can't treat this as 2 resistors in parallel, because the diode completely changes things. Now for the first part of the question, is actually a very easy question if you read the question. You've got a battery there. You've got an 8 ohm resistor that is connected across the terminals of the battery. It's also in parallel with some other components, but that doesn't matter. If you're asked to find the current in that resistor, there's the resistor connected to the battery, so it's really easy to find the current. I equals V over R equals 12 divided by, well, it's actually 12.0, let's be consistent with what the thing does. 12.0 divided by 8.0, which is 1.5 amps. A lot of people got that right. Quite a number of people got it wrong because they didn't read the question. They immediately started working out the parallel resistance, which you can't do because the diode's there, and which you didn't need to do anyway, because if you've read the blooming question, it just wants the current in that resistor. Next part, calculate the current in the 4 ohm resistor if the PD across the diode, when in forward bias, in other words when it's conducting, when it's kept to the right way around, is 0.65 volts. So, the current in the 4 ohm resistor, if the PD across the diode is 0.65 volts. So if you've got 0.65 volts there, what's the voltage across the 4 ohm resistor? Well, those two things are in series with each other. They're connected to a 12 volt battery. So the voltage across the 4 ohm resistor must be 12 minus 0.65. So the current, 12.0 minus 0.65. That's the voltage across that resistor divided by its resistance. Which gives us an answer of my calculator says 2.84. But it says an appropriate number of significant figures, and we'll look at the data we've been using. The resistor was only given to 2 significant figures, so the answer should only be to 2 significant figures. So I'll put my answer as 2.8 amps. And if I'd put 2.84, I would have lost a mark, because there is a mark for significant figures. So to find the current in the resistor, so to find the current in the resistor is the voltage across the resistor, which is 12.0 minus 0.65 divided by the resistance, which is 4.0. And my calculator gives that as 2.84 amps. But it does point out in the question, use an appropriate number of significant figures. And I've got 3 significant figures in that answer, but when I look back to the question, the resistance was only given to 2 significant figures, so I can only give my answer to 2 significant figures. So I should write 2.8 amps.